So now for the Xarray, for the introduction, I say Xarray, what we call Xarray is, we are using, in this one we will discuss what is Xarray and how does Xarray fit with NumPy and Pandas, and then creating a data array and open an NetCDF file using Xarray, and then how we can subset. Because in this case we are discussing about multi-dimension. So far we discuss only one dimension, no 2D data. We only discuss about one table. Now we are planning to load the data with like multi-dimension. So if it is like daily data, then we will have like multiple stack layers stored in a single file. So now we need to cut. That's why in this cube it is like this cube. So you will have like multiple variables with 3D. This one you can imagine, okay, this one has latitude and this one has longitude. So one slice means a map data. So one grid means the value, actual value of that cell. So we discuss about this spatial resolution thing called. When we are discussing about like in GIS courses, we discuss Landsat has 30-meter resolution and then Sentinel has like 10-meter downscale resolution or something. So that resolution means this one grid is equal to, in real world, it will denote like our entire data set will be something like this. Okay, the entire resolution will be like this. But for the minimum block or minimum cell, this one will be 10 meter by 10 meter when it comes to Landsat. If it is MODIS, sometimes it will be like 250 by 250 or 500 by 500. But then our entire data will be like divided into these kind of cells and we store the data accordingly in this cell value. So now how we can access this data? So before we go ahead, we need to like know about the structure of the NetCDF files. Before you play with any kind of data, you need to understand the structure. So for that thing, we will load NumPy and Xarray to discuss on how we can do this thing. So in here, we so you need to know that we need to have like coordinate names and the values. If it is an NetCDF file, we need to have coordinate names and name values. Then we should be able to make some slicing and indexing and much more powerful things. So now we will try to create some Xarray data, then you will understand the structure. So first we will import NumPy and Xarray to create some sample data, and then now what we are creating data, we are adding 825 plus 5, that means it will multiply by this random number and create some sample data. So if I print the data, it will be something like this. So this will be what kind of data? So how many columns are there? 1, 2, 3, 4. 4 columns. And how many rows are there? 1, 2, 3. So how many dimensions are there? 1, 2, 3, 4, 5. So here you can, from here you can see, I am saying at the end, I am saying randomly organize this one to 5 dimensions, that means 5 tables, and then 3 rows and 4 columns. So just I am creating some sample data. Now you can imagine I have. So if you type how to view the dimension of this one. So I discussed about this one previously. Whenever you need to view the dimension, you can type that command. I discussed this thing previously when I am discussing Xarray Pandas. So whenever you need to check the dimension, you can type ND. Then it will give you the dimension. So this one is 3 dimension. So now how I can convert these values into an Xarray data format. So to convert it into Xarray data, so you can call for Xarray. So in here I imported Xarray as XR. So now I am calling XR data array. So whenever you need to convert something into a data array, there's an inbuilt function called data array. It will convert all the values or NumPy arrays that you have created into Xarray data format. So now if I view this one, now you have something different. So in here, this one is array type data. No, in here you don't have anything. you only have these values. But after you convert in this one into Xarray dataset, you can see a difference. So what are the difference? You see in here. You see Xarray data array, then dimension, and then dim, and then another dimension. So it is mentioning the dimension. This will be the number of tables or number of like separate data sets that you have, and then the columns and then the rows. So when you load the actual data, you will see this one. And then these are the values. And then you have something called coordinates. And then you have something called indexes. And then you have something called attributes. So in NumPy array or like pandas, you don't have something like this. But when it comes to Xarray, you should be see these variables whenever you load the data. This time we created the sample data to understand how this is going on. Now for this data set, we can pass our own dimension names. Now in here, we have empty dimensions. We don't know what these dimensions mean. So now we need to pass the values for exact like each and every dimension. So in this case, you can imagine, okay, these are like you can divide. If it is a single table, we can divide these tables. Like just imagine we have like five tables, no? So one table contains how many rows? 1, 2, 3, 4. So 4 rows are there. And then we have 4 columns and 3 rows. And now we have the same table. We will have like how many tables? 5 tables will be stacked together. So now you can simply understand this one like how? You can say, okay, this one is latitude, this one is longitude, and this one single table represent a time stamp. This one will be like, okay, if it is monthly, you can imagine as this one will be month, first month, and this one will be for second month, and this one will be for third month, and this one likewise you can say, okay, it is monthly. Now we are going to label this each and every individual dimension. So in this case, we can call Xarray data array, then data. When we are creating the data, if you view the docstring of like data array function, you will see you can pass data, and then you can pass coordinates, and then you can pass dimensions, and then you can pass names, then you can pass attribute, and even indexes, and then pass path and everything. This time we are going to pass indexes like dimension names. So how we can pass the dimension names? If I view the docstring over there, it should have mentioned how you can pass the dimension. If your data set has some dimensions, how you can pass the dimension names. So you can see on here how to pass the dimension. But in this case, I know how to pass it. So first you need to give your dataset name, and then you have to say, okay, dimensions. Now I know how many dimensions are there in my Excel, like NumPy dataset. I had 3 dimensions. So now my NumPy dataset is in 3 dimensions. So I know I need to pass 3 values for my dimension. So now I can assign, okay, I know the structure as well. I have 5 separate like same values, that means 5 tables. Then those tables demarcating some time step, and then columns will represent latitudes and rows will represent longitude. So now I am going to pass this one. So after passing this one, what will happen? Now if I view the data, now it is saying time, I have 5 time steps, and for latitude levels I have 3 latitude levels, and longitude levels I have 4 longitude levels. What is the purpose of this one? Just imagine when you are going to plot some data, you need to extract one time dimension of one thing. So you can call, okay, time equals 1, give me the first slice. So what will happen? It will slice, it will take only this table and store separately as a data. Even if you need to get like average, you can assign, okay, calculate the average according to the dimension name type. So what will happen? It will do the calculation, it will get each cell value and across all the months and calculate the mean value for that cell. It will keep repeating for all these cells and ended up with one single average grid data. That's why we need dimension names. So in this case, we have dimensions. label. Now we have dimension 1 as times, and then dimension 2 as longitudes, and dimension 3 as longitudes. So now we will call for pandas as well, because we can pass some other data, like if we need to create date range or something, we can use pandas. Now I am importing pandas because we discussed about pandas earlier. From panda, there's an inbuilt command date range. So if I call for that command, what will happen? It will create date ranges. So first one will be my starting point, and I am saying period of 5. So if I do something like this, what will happen? It is creating me dates with the timestamp of time period of 5. So if you see the docu string, you can see it is returning a fixed frequency of date type index. So I am specified period as 5, so it should give me 5 interval. That means 2018, January 1st, and then January 2nd, January 3rd, January 4th, January 5th. So when you are opening the data set, you don't need these things. But to understand the data, that's why we are doing this. Now we are creating times because we need to pass. Okay, now we have time dimension, but we need to name these 5 dimensions. Okay, now we have 5 time slices. But the problem is we didn't mention, okay, what does this time 1 means? Right now in the data, I didn't mention, okay, no one knows what does time 1 means. Now I am going to say, okay, time 1 represent the data for this specific date. If it is time 2, is going to represent the second specific date. If it is time 3, it is going to represent the third specific date. So this is how the NetCDF file created. This is like we call, at the end I will discuss, this is what we call CF convention. So just imagine if multiple institute is going to like output their data according to their own format. What will happen? Then all the scientists and everyone around the world, they need to know, okay, these guys are giving us the output in this format. We need to know like how to read this data structure. But right now they are using the same structure when they are processing the data. So everyone will understand this data structure. Now I am creating this time stamp, and now even I am creating longitudes and latitudes. So how many longitudes I have over there in my actual data frame in here? So according to this one, I have 3 latitude levels and 4 longitudes levels. So now I need to name these dimensions, give the values for each dimension. So for that thing, I will also create a line space between 120, 40. We discuss about this one. What is the purpose of line space command? We discuss about line space and arrange. What is the difference between line space and arrange? It will give us 4 equally spaced values between these 2 ranges, and then I am asking latitudes, give some values in between these 2 values, 3 values, because I need 3 latitude values and 4 longitude values to name, like give for these latitudes and longitudes. So I will create latitudes and longitudes values as well. Now I can say, okay, this is the way that we can convert NumPy array into a Xarray data type. Now when creating the data type, first you need to give data. Second value will be, you are passing your dimension names. Now I am passing, the coordinates. That means the dimension values. This one you can like Swift, like you can give the dimension name first and then you can give the values. In here I am passing the coordinates for each dimension. That means actual values of each dimension. So now for times, it will assign time 1 as first time date, like 2018 January 1st. And then for latitude 1, it will give these values. If I print the lat and long values, you can see it will pass these latitude and longitudes values. So it should be 80 years. So I have 3 values, and even for loans, if I type loans, it will give me 4 values. Now it is going to assign these values. If I execute this command, what will happen at the end? So here I have time, latitude, longitude. But if I scroll down, here you can see I have time, how many values? So if you click here, you can see all the values. I have 1, 2, 3, 4, 5. and then if I view the longitude, I have 1, 2, 3, and then for latitude I have, longitude I have 4, and latitude I have 3 values. But previously I don't have the coordinates values in here. I only label the dimension name. But right now, if you see the dataset name, you can see dimension name is also like highlighted and it displays in bold color. Previously, it doesn't highlighted or show me in a bold color. So now you know why we may like label these things, why we are labeling these things. So whenever we are going to do a calculation, it will be easy for us. Even now we can slice the data according to this date frame. Like just imagine if we have like multiple years in here, we can call from the dimension name, select these years. So it will select the specific data range and slices and give us for our own calculation. So that's why we need to have coordinates. Now the next one is we need to give like attributes. Okay, now we are saying okay, this entire data is representing, okay, now this set of data, this entire set of data is representing temperature value. But we don't know what is the like unit of that temperature value. How we can assign the unit? Because I say at the beginning in here, if you see this one cube represent one variable. In NetCDF files, we will have like multiple variables. So how we can have that thing? Now we have one single cube, but the problem is we need to label this value. What is the unit and what is the variable name of this specific data? For that thing, we can say, okay, there's one name called attribute. Now we are going to pass attributes. In here you say coordinates. Okay, now we have all the coordinates, and now we need to pass indexes. If you see the indexes, we have time, latitude and longitude, but for the attribute we don't have anything. Now we are going to pass the attributes. So now we are saying temperature, that means our this Xarray data set dot attributes. In like there are some inbuilt attribute types that you can use. Now I am going to assign attribute name units and assign it as Kelvin. So what will happen? So now if I send this data set to someone, he knows all of these values represent temperature in Kelvin. Otherwise, if I didn't mention this one, whether it is Kelvin or Celsius, no one knows. If I pass the data something like this, he doesn't even know whether this is like pressure values or any sort of other value. So I need to label the attributes. I am saying, okay, units in Kelvin and the name as air temperature. Now if I execute this one, what will happen? So here you can see now the attribute, we have two different attribute names. We have unit in Kelvin and standard name in air temperature. So when we load the data, you will understand why we are doing this. When we read some NetCDF file, you will understand. Right now, you don't know why we are doing this thing, but you need to understand we are doing this one for a specific purpose. So now, how we can convert? Now, okay, I have the temperature value. How I can convert these all the values like a same simple mathematical equation. I need to convert these all the values into Celsius. How we can convert these like values in Kelvin to the Celsius? What is the command? Simple calculation, no? How we can convert values in Kelvin to Celsius? So Kelvin to Celsius, we need to subtract the values in Kelvin by 273.15. So now we are calling for our variable name and doing this one. What will happen now? So it convert all the values, not a specific value or specific table. It convert the entire Xarray data series like Xarray data to the Celsius values. But the problem is here the attribute. Now you can see after doing the calculation, even the attribute names are gone. So you need to understand whenever you do a calculation, attribute names will be go away. If you try to save this NetCDF file and try to send it to someone, it's better to label the attribute as well. So now is the thing is like how we can select this data according to our own need. Just imagine I don't need the entire data set. I don't need this entire data set. I only need one time step. Now the time dimension is also there. I even label the time dimension. So how I can access one table from here? Now we call this one as slicing or selection in this one. For selection, the short command is dot cell. If we call for Xarray data dot cell, it will start selecting a dimension or anything that we are going to call. Now here in I am calling temperature dot select. Then the dimension name is time. Why I am typing time in here? Because I have a coordinate name time, and then I am assigning access the time 2018 January 2nd, because from here I know I have 2018 January 2nd. So at the end, what should it give me? It should access the second data set, that means this data set, and print this data set for me, and dimension will be reduced. So now we have time, latitude and longitude, but we are saying select one time frame. Then what will happen? Dimension will be reduced. Now I will end up with 3D data or 2D data. After I execute this command, I will end up with 2D data or 3D data. I will end up with 2D data, because why? I am saying I only need one single time step. Then I don't have the rest of the time stamps. I will only end up with one time stamp. So here you can see I only have latitude and longitude. Why? Because I say, okay, from this entire data set, just give me only that time frame. So now it reduced into 2-dimension data set. So even when you are selecting, you can give multiple time stamps. Right now I only assign one time stamp. That's why it's giving me a single time stamp. Okay, how I can access this time stamp? I can just copy this one. Either I can copy or type. The best thing is like you can view your data set and like you can specify the dates. So I can copy this one and paste it in here. So what will happen? It will give me the specific table for that time dimension. So in our case, it should give me this data set. So if I execute this one, it is giving me that specific table. So you can see from here. And then that's the main thing, you can like use i.select command to select these selections. And then now I am saying this one is like in selection we have a flexibility like nearest neighboring sample. So now you know in selection, if I type okay, something like this, what will happen? 17. If I type January 7, what will happen? In our data, do we have January 7th data? We don't have. In our data frame, we only have the data from January 1st to January 5th. So if I type in here as 7, what will happen? It should give me an error. But there is something called like nearest neighboring. We can say, okay, don't select, give me the exact value. If there is a closest value to like this one, it can pass, because you know when it comes to latitude and longitude, we specify specific latitudes and longitudes. No? Now when we going to access a specific latitude and longitude range, that means we are going to click for a specific country. During our first class CDO and grads, we mentioned whenever you have the entire world data, it will stored in this kind of NetCDF one table. If it is a world like global temperature, we are going to access like one NetCDF file. It should store like it. If it is like entire world is there, it will stored in a grid like this. And for first month temperature, it will stored in time January 1st or something like that variable. But now this one is divided for minus 180 to positive 180. And this one is divided from 90 to minus 90. This one will be like 0. So now if we need to get a specific country, we need to specify these latitudes and longitudes. But when we are specifying over there, they divided these things into not equally like space. It should be like there, it will contain like 0.5 or something for these division lines. But when we are focusing on our country, we should be able to go for the closest value. We don't need the exact value, just give us the nearest value. how we can do that one? So for that, we have an inbuilt command in here, something called nearest. So if you view the docstring of the selection function, you will see we can give the index and then the tolerance, and then we can give the method and some other function. So in here, we can give the method as nearest. So what will happen? If we assign the method as nearest, when we are selecting a data, we assign, okay, method is nearest. What will happen? Nearest means just give us the closest date for this value in our data set. But to do this thing, we need to give, like I am saying, tolerance. In here, I am assigning tolerance as well. What does tolerance mean? So plus minus 2. So that means if the date I am passing is January 1st, January 7th, I am assigning tolerance as plus minus 2. If minus 2 this one, what should be the value? Plus minus 2, 5. So I am saying 5, and if it is plus 9, so it should be either 5 or either 9, or in between these two values. Actually here tolerance we say like this 2, but we know Python is 0 base. So what will happen? It should go still 4. This one should go still 4. Like we have like actually the Python is like 0 base. So if we assign 2, that means 3 days. So other way it should go for 10 days. If it is seeing like any sort of values in between this one, 4, 6, and then 4, 5, 6, 7, and then 8, 9. If this one can see one of these days, give us that value, but it should be closer to 7. So now what will happen? For this one, we are calling to call for this time delta. We have to call for date time. Date time is an inbuilt function like calendar. So we are using calendar when we need something related to monthly names or like calendar format. We are calling for date time. We need something related to date and time both. So if we call like date time, there's an inbuilt function called time delta. It will give us a function name this one, time delta. So we can assign like array with a specific date range. So now if I execute, what will happen? Last time you saw it was giving me an error when I type 7. So in here, if I type only the 7, you see it is giving me an error. But now I am saying, oh, this one is stopped. So here it is giving me an error. But now if I type this command, you can see it is not giving me an error. So because in here it is saying not all values found in the index type, try setting the method. So it is saying try to set the method keyword inside the command and try to pass it. So method should be nearer. So it is giving me an error like hint as well inside the error. So now I can pass time, then method is nearest, then the tolerance is 0.2. If I didn't mention this one, what will happen? If I didn't mention this one, what will happen? It is also giving me an output, but the problem is it is not giving me that tolerance within that range. If I specify that tolerance, then it will give me the closest value, because I am specifying, okay, try to check for a value in between these state ranges. So if you need to do that thing, then you need to assign tolerance as well. Then when you assign the tolerance, it will go and check for the days, and then it will return you the value. So in here it is saying we have the data for January 5th. So it is giving us the value for January 5th. Because in our data set, if we view our data set, like the entire data set, we know how many days we have over there. From January 1 to January 5th is there. So it is giving us the closest date range. So if we see the tolerance in here, if we reduce this one to 1 or something, what will happen? It is giving us error. It is saying no data values ranging between the time period. Because if we set the date like tolerance to 1, what will happen? It will go for +1 and +2. So within these date ranges, we don't have any variable. And then now you have an exercise. So you can use the same thing. So you can set using select function to select the forecast for this one. So how you can do, you can use this interpolate command, interpret command. You can view the document stream for this interpret command over there in the Xarray. If you go into the guidance, it is saying one-dimensional interpolation. So how we can do? Now we need to do a interpolation solution. So if we see this one, how we can see interpolate longitude 105, latitude 40. So what will happen? So let me check my temperature data first. So when I see the temperature data in the latitude and longitude, what are the values that I have in here? 25, 40, 55. And in here I have 120, 100, 80, 60. Now how I can see, okay, I need the longitude value of 105 and latitude value of 40. But I have latitude value of 40, but I don't have the longitude value of 105. In here I don't have the 105, but I have latitude value for 40. So if I execute this one, what will happen? I have longitude value 105, latitude value as 40. How it become? Because in here I don't have a longitude value name 105, but after I run this command interpolate longitude to 105, latitude to 40, it give me an exact value. So when you are focusing on latitude and longitude, you can go with a function called interpolation. What it is doing? It is getting the nearest values and doing the interpolation part and calculating a value for that specific area. Now I am saying I need the value for this specific column. So at the end I ended up with the range like this. So what is this mean? What does actually this one meaning? The meaning of this one. So our data set is like this, no? We have multiple tables, 5 tables. So we have 5 tables in here. So I say this one will be longitude and this one will be latitude. And now we are specifying latitude as 40 and longitude as 105. So we are accessing a single point in here. What will happen? If I access a single point, but I didn't specify the time. So what will happen? For the first time stamp, it will access this point and give me a value. For the second time stamp, it will access this point and give me a value. Likewise, it will access for all the values. Here, at the end, I ended up with 5 values because of that thing. So this is how you can create a time series. So just imagine you load a temperature data from a provider like NOAA or NASA or any other like websites, you can find the data. But now you need to convert it into a time series to plot a graph like a temperature graph as we discussed earlier. Last time we discussed how to do it using text files and CSV. But now if we need to do it using a NetCDF file, we can do. Like simple command like this, you can extract the time series data. Now we are accessing the time series data from here, and then, but there's an issue. When I am accessing this one, there is no 105 in my latitude. I am asking what is the closest values between 100 and 5. Minus 100 and 5. What is the closest value between minus 100 and 5? So it should be within these two cells. So I am calling for interpolation. Now what will happen? It will create the value range from this minus 120 to minus 100 values, and then I am asking for interpolation. It will do the calculation automatically and go for 100 and minus 105 and create a value for this specific point. That's why I am calling for interpolation function, where you don't have a like specific array, specific value for that one. You need to call for interpolation. Then it will do the interpolation and calculate the value. In the interpolation, what it is doing is it is creating, like during ArcGIS, did we do an like interpolation example, like getting a temperature values for multiple stations and did the interpolation. We didn't do anything like that, no? Like getting the IDW or Kring interpolation, we didn't do. So something like that is happening in like behind and giving us the exact values. So that's how you can do interpolation when you don't have a specific latitude or specific longitude. For the time, you can do this one. If it is a time dimension, what you can do, you can say method nearest, and then you can assign the tolerance. If you didn't assign the tolerance, what will happen? It will select the nearest time according to its needs. But if we need like a closer time frame, like within a time frame that we assign, we need to assign the tolerance. But the latitude and longitude, if it doesn't have the specific latitude and longitude in our data set, we need to call for interpolate to get an exact value for that specific range. Because in here, if you check for the values, these values are not here in the table. You cannot find these values in the table. 27765, you don't have that value in this table. But if you check on these two lines, longitude is 120 and 100, so it should be between these two values. No, it should be between these two values, the last value. So now if you check on the last value, it is 277.65 something. So it should be closer to 100, because from the coordinate we know 100 and minus 120 and 100 is relying between these two columns. So it should closer to this value, not to this value. Now if you check on the value, you can see 277.6 is much more closer to this value. So now how we can slide with a selection? Last time we slice only with one time step. Like if we do a slicing, now the same command, the select command we discussed about earlier, now we are saying slices. What will happen? If I execute a command like this, what will happen? I am saying time, now I am saying slice. So now I am asking to cut the data. So what will happen? From this 5 separate data frame, I am asking go for first time stamp to January 3. That means go for first 3. Skip these last 2. Just select these 3. Now it will select that 3. No, like here, yeah, let me execute this one, then we can see. So just 2, yeah, it's just 2. If you see this one, not just 2, it is like the range. Actually, it is the range. So it will select the entire range, because if you specify slice command, it is not selecting like those 2 points. It is selecting the entire range. So if we specify, this one will be the starting point and this one will be the ending point. So now if I say slice only this one, what will happen? If I didn't put this part, if I delete this one from the command, what will happen? It should like slice according to these dates. But now after comma, I am saying slice the longitudes as well. I am saying 110 to minus 7, because in now my data set, if I view for the latitude levels, I should have those two values as my latitudes and longitudes, 110 to 70. So I don't have 70, but it will go for 70. It will do the nearest neighboring thing and then slice 25 to 45. So this is the way actually that you can focus on your own country. if you have like the entire world data set, now you need to extract a specific part for your own country, but you don't need to specify time. So you can delete this part. If you remove this part, what will happen? It will not focus on the time stamps, but it will focus on latitude and longitude and clip the area that you specifically focus on. And then it will subset the data by removing these parts and focusing on only these latitudes and longitudes. And at the end, we will end up with this kind of data series. So that's how you can slice your data. So after slicing, you can see still we have the time step. Time stamp is reduced because we only have 2 time steps, and latitude is also reduced because in between these two values, if we check on our latitudes, the actual latitudes, you can see temp. If I see the actual data set, you can see I have latitude levels and longitude levels 4. Latitudes are ranging from 25 to 40 to 55, and then longitudes are ranging from this. But in here I am saying slice longitude 110 to 70. So 110 to 70, I should have only 2 because here I don't have another value. For slicing between latitudes, it is like 25 to 45. If I focus on here, 25, 40 and then 45. So that's why in this command, after executing this command, it is reduced to 2 latitudes and 2 longitudes. So now you know how to do this one. Even we have another command, this one is select. And now we are going to discuss about loc. So if we discuss about loc, what the loc command means, it is also same. It is also same like above. But the thing is, in here we don't need to provide the dimension names, because when we are calling for slicing, we call for dimension names. Can we call this one as times? Can we call this one as times or any other variable name like times or t? Can we call this one as times or t? Why? Because in our actual data we have the dimension name as time, latitude and longitude. So you have to check this one. After you load in the data, first you need to inspect the data. If your data set has like this dimension is named as latitude, then you have to call for latitude, not like lat. In this case, I call for lat because in my data, I call this dimension as lat. But in your scenario, after you load the data, that dimension name is latitude, that means you need to call for that dimension name as latitude. But in here, when it comes to like loc, we don't need to call for dimension names. So if I execute something like this, what will happen? Temp loc equal 2018 1 2. What will happen? Oh, it is stuck. So if I execute this one, you can see it select the type, because you know in your case, in our case, first dimension is time. So if I view the data set, first dimension is time and then latitude and then longitude. So whenever I call loc within 2 curly brackets, I call for the time, it knows I am asking for this specific type. So I don't need to specify the dimension. And then I am saying something like this. If I specify something like this within 2 quotation marks and then 25 to 40 and minus 110 to minus 70. So what will happen? It is processing accordingly. So this one should be time, this one should be latitude, this one should be longitude, because in my actual data set, the format is like that. First one is time, the second dimension is what we call longitude, I think latitude. Second dimension is latitude, third dimension is longitude. This is in my case. But when you load the data in that data set, it can be other way around. It can be like latitude, then longitude, and then time. So when you do this one, what should be the command? Just imagine if I execute something like this, what will happen? If I execute something like this, what will happen? Now I am saying the first value is longitude, second data range is latitude, third data range is time. But in my actual thing, it's like time, latitude, longitude. Will this one work? It is not going to work. Why? Because when we are using log to do slicing like that, we need to check our dimension, arrangement of the dimension first. If our dimensions are arranged like this, then we need to call for the location function. First, we need to specify the time range. Next, we need to specify the latitude range. At the end, we need to specify the longitude range. But if your data is arranged like this, then you can call for latitude range first, longitude range first, then second, and then the time range as third. So you have to check your data before you do something like this. So what will be the best command? You can either go with log or you can go with select. But the best way is like going with select, because over there you are specifying, okay, select this specific dimension and do the reduction accordingly. So now we are going to open a NetCDF file. Till now we discussed how to we build our own dataset to understand the structure of NetCDF file. Now we are going to read a NetCDF file from Nova. So how we can access this NetCDF file? To access this NetCDF file, I send the NetCDF file in the group. So you can download that NetCDF file and save in your location where you save the script file. So I will save this one. I save this one is in the D. I save this one in workshop file. In Xarray, I can save this file in here. So after saving, you will see the file in that same directory. Now in Xarray, after loading Xarray, we need to import the Xarray first in here. At the very top, I import Xarray. That's why I didn't type this one as in here. When we are importing Xarray, what should be the command? Import Xarray as XR. Now we import the Xarray. After that, we can call xr.openDataset. So in XR, like Xarray, there's a function named openDataset. So this data, like openDataset function, can open multiple type of data: NetCDF, GRIB, HDF. So there are other formats that you can open. But in our case, we will open this specific file. So now you need to delete these other lines and you can specify the file name. What I can do, I can copy the file name from here and paste it over there. So I will copy the file name from here, rename, and I can select the entire thing and copy and paste it in here. So now I can, it will load the dataset. It will take some time. After loading the dataset, you will see how many dimensions are there. So we can have like multiple dimensions. In this case, how many dimensions are there? We have 4 dimensions. One is time, other one is isobaric, and the other one is y, and the next one is x. And then for the coordinate, it is saying us time, and then isobaric level values, and then y values and x values. And for the data variables, we have how many variables? U component of the wind, and then we have the Lambert computer projection, and then latitude, longitude. We have multiple variables: V component of the isobaric wind, geopotential height, and then temperature isobaric. And indexes, if we view for the indexes and the attributes, if we view for the attributes, you can see in the attribute it is mentioning the agency that this data is providing and the version of the tabular format that they have used, GRIB, and then the convention, CF convention format, and then some other functionalities. So now how I can access one coordinate of this one? So I can call ds.isobaric. So if you type ds, and then dot hit tab, it should give you all the commands that you can access with this ds data. So here I have multiple functions, but if I type ds dot iso, so it should give me isobaric. So if I view this one, now I can see the isobaric values of this specific data set. So if I need to check x values or times values, how I can do this one? If I need to x values or y values, how I can do? I just need to type ds dot x. So likewise, you can see all the x values. So for that thing, first you need to check for your data set, and after that you can select the specific names. Now other thing is you can use this indexing thing, like we discussed about this one, how we can do the indexing. You can call for the function name, same like selecting the variable. There's two options, either this one or this one. Both will work. So now we have that thing, and now how we can select a specific level. ds select isobaric equal 1000, what will happen? If I say ds select isobaric equal 1000, because in isobaric levels I see isobaric means the different pressure levels. So how many pressure levels? The sea level pressure we considered as 1000. When it goes to up, we will see like 100. Pressure is decreasing with the height. So typically we will consider 1000 as the sea level pressure, and then minus 100 as above levels. So we know pressure is decreasing with the height. That means we are accessing ground level information. If it is 1000, it is around here. 100, it will be the uppermost layer. So now we need to access the isobaric level 1000 data. How we can use this one? We discussed from dataset, select, we have dimension name isobaric. Over there we have this dimension, and we see 1000. I am saying select 1000. Then I can see the values, rest of the values at that 1000 level, because here now the dimension is also reduced from 4 dimensions to 1 dimension, because I select isobaric level only one isobaric level. Now I can type ds dot temperature at isobaric. So in here you can see I have data variable name temperature dot isobaric. So now I am going to access this temperature data. So either you can copy this one or you can type ds1000. So ds1000 means isobaric level 1000. From there, this is the data set. From there I am saying access this variable temperature at isobaric levels. I am saying dot temp. If I hit the tab, it should give me the available variable. So I have available variable temperature at isobaric. So now what will happen? Now it is accessing the day, like the temperature values for that specific command. But here I have how many values? 31,892. So it cannot display all the values. So that's why it's showing something like this. So now I need to access U component of the wind. How I can access the U component or V component of the wind from here? Because in the data variables we see U component of the wind, Lambert coefficient projection geometric height, V component temperature. Now how we can access U component of wind? There are two ways we discuss. Otherwise you can type your actual variable name. Otherwise I can type ds within bracket, I can call for the variable name. So now I am accessing that one, and I am saying the standard deviation dimension will be x and y. So how we can like calculate this one, like slicing, and then we can control aggregate operations like sum. Now in this case we are calculating the standard deviation of u component of the wind. So how we can do the calculation like that? There first we need to extract the values. So now we are extracting the u component of wind values at the isobaric level, and then we are saying u wind those standard deviation dimensions. Because after I export this one, let me type this one in a separate command line and type u underscore wind which should be winds. So now I have these values, and now you can see I have x and y. Now I need to calculate the standard deviation between this x and y dimensions. So I can do a calculation u wins dot standard deviation of dimensions x and y. If I run this one, you can see it is calculating the standard deviation values in the dimension of x and y. Now x and y is reduced from here, because y I calculate the standard deviation for these two coordinates. So it will simplify and remove those two coordinates. So now we can do a simple exercise. So we can select these two x ranges, like x value is ranging between 182 kilometers and 424 kilometers, and y values we need to select from 140 kilometers to 990 kilometers. Because if we see the data set, let me print the DS. So in our data set, we have x and y values. So for x values, if we view all the x values, you can see x values are ranging between multiple values. Here we have in the scientific notation plus 2 mean 400, plus 2 mean in here it is 600 and 600 16.69 or something. So now we need to slice data accordingly. Now how we can do the slicing to select the specific variable and plot. Now for this one, how we can do? So we can select the temperature at isobaric level, because I am saying calculate the mean temperature profile in this specific level. So how we can access the temperature level? We can access the temperature data set using ds dot temperature at isobaric level. So it will give us the temperature value. So this will be the first slide. If I execute this one, what is happening? And then if I view temps, I should see the temperature values. All the other coordinates has been omitted, and I will end up with the temperature value at the isobaric level. Now I am saying from temps select x, because I need to slice. We discuss about slicing. Now I mentioned you need to focus only on this range. X range should be 182 to 424, and Y range between 1450 to 990. So how we can set these slices? We can set X slice from 182 to 424, and then Y slice from 1450 to 990. So now we slice the data, and then I am asking to calculate the mean temperature profile. So now we selected this range and we selected the temperature. Now we need to do the calculation for mean. So when we are calculating the mean, we have to select, okay, calculate the mean for these two dimensions, x and y. So now it should give us the mean value at the end. So now you can see we will end up with mean values for all the isobaric levels, because we sum the dimension in here. We say how many times, like in times variable, like time dimension, we only have one value. In isobaric dimension, how many levels we have? 29 levels. And I am asking to calculate the mean temperature value for each isobaric level within this grid. So if we set the dimension as x and y, it will simplify and give me 29 values at the end. So if you see here, I will end up with 29 values for each single isobaric level. So this is the way you can do simple calculations using Xarray. So what's the time now? 5:09. Because you need to understand about this concept. to go with cartopy. To like next day we discuss about cartopy, then we will go with spatial plotting, because now you know how to do these things. Because now just imagine if you get single array like this, you can do plotting as well. Now you know how to reduce the dimension and how to do the plotting. So yeah, now you can go with simple like one dimension plotting, like a time series or a scatter plot. But now you don't know how to do a spatial plot. So we need to discuss about a spatial plot.